In this video, we're going to see how to perform a multiple linear regression, an analysis when we have one continuous outcome variable that we want to predict on the basis of several continuous or categorical explanatory variables. For this example, I'm using the big class dataset available in the sample data directory. To start this analysis, I'm going to go to Analyze, Fit Model. Fit Model is a general modeling platform, and like all platforms in JMP, the output is contextualized on the basis of the variable types you give it. In this case, we're going to be predicting weight of each student, a continuous variable, on the basis of several of these other predictors. Notice that entering weight into the y changes the personality of this model to standard least squares, as that's what we'll be using to predict a continuous outcome variable. I'm going to use several of these predictors, age, sex, and height, in my model effects. I'll start with the categorical variables of age and sex, and cast them into the model effects by clicking Add. Notice here that age has its modeling type set to ordinal rather than continuous, despite the fact that we have numeric entries for age in this dataset. This is important to do sometimes if you would rather JMP fit separate means for each age rather than a continuous response function predicting weight. I'm going to select height as well and add this to my model effects. And because I'm interested, I want to fit the height by age interaction in this model. To get the interaction, I'll select height under the model effects, select age in the columns, and click cross. This will create for us the bilinear interaction between these variables without us having to create separate columns in our dataset. When I click Run, JMP will produce the multiple regression output, showing first for the whole model the actual by predicted plot. This is useful for diagnosing the overall predictability of the model in representing weight of each student. For each of our other variables, we also get leverage plots showing us the unique effect of that variable holding constant all the other variables. For categorical variables, we also get the least squares means table, showing us the least squares means for every observed level within that variable. For hypothesis tests on the effect of a given source, we can scroll down to Effect Tests, which shows us the F-test, or the main effect, for any given source in our model. We can see that age and height show statistically significant effects on the weight of students, holding constant all other variables in the model, but sex and the interaction between height and age do not show a statistically significant effect on the weight of students. The parameter estimates section is also of interest if you're looking for the actual beta estimates for each of your parameters. Notice that for ordinal or nominal variables, JMP shows you the parameterized estimates for these variables. So age here has 5 of the categories listed, since the 6th is redundant, and sex shows 1 of the categories, since the 2nd is redundant. JMP also produces by default the residual by predicted plot, allowing you at a glance to diagnose whether you have issues with the assumptions of your model. Under the red triangle, JMP also has many different options for diagnosing your model or for interpreting the effects. Under factor profiling, the profiler is a very useful tool for understanding the relationships you've modeled. In the factor profiler, we see each of our variables with one particular level dialed in. If we change to any other level, we can see how the response function is changing on the basis of the values in that variable. Finally, if you're comparing the prediction from several different models, JMP makes it easy to save the predicted values or the prediction formula under the red triangle, Save Columns, and Prediction Formula. This will save to your dataset the actual prediction formula as a formula in the column. Selecting the formula shows the method by which JMP is saving this, and for any observation in your dataset, will reveal the prediction from this model.